So next, we shall solve the problems based on dual nature of radiation. So in that, first we shall see first problem, that is 11.1. Find the maximum frequency. B1 ಕೇಳಿದರೆ minimum wavelength of X-rays produced by 30 kilovolt electrons anta ಕೇಳಿದಾರ. So let us see how to solve that one. So that is 11.1. So find first one maximum frequency, second one minimum wavelength of X-rays produced by 30 kilovolt electron. First we shall solve 11.1. So here 11.1. So from the question, so potential of electron V they have given, that is 30 kilovolt. ಅದನ್ನ ಹೆಂಗ್ ಬರಿಬಹುದು? 3 into 10 to the power of 4 volt ಅಂತ ಬರಿಬಹುದು. Energy of electron E value they have given, that is 3 into 10 to the power of 4 electron volt. E ಅಂದ್ರೆ charge of the electron ಯಾವಾಗಲೂ ಅದರದ್ದು ಕಾನ್ಸ್ಟೆಂಟ್ 1.6 into 10 to the power of minus 19 coulomb. So first one they asked to calculate maximum frequency ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಹೇಳಿದಾರ. So that is given by in order to calculate that one, nu anta ತಗೊಳ್ಳೋಣ. So energy of the electron is given by the formula E is equal to h into nu. H is nothing but Planck's constant. So we have to calculate nu is equal to E divided by h. E formula ಹಾಕಿ calculate ಮಾಡಿದಾಗ, so E value ಎಷ್ಟೈತಿ? 1.6 into 10 to the power of minus 19 into 3 into 10 to the power of 4 divided by 6.626 into 10 to the power of minus 34 ಅನ್ನ simplify ಮಾಡಿದಾಗ nu we got, that is 7.24 into 10 to the power of 18 hertz ಅಂತ ಬಂತು. Hence maximum frequency of X-ray produced is 7.24 into 10 to the power of 18 hertz ಅಂತ ಎಸಿಗೆ ಆನ್ಸರ್. ಇನ್ನು B1 ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಂದಾರ? ಸೊ B1 ವೇವ್ ಲೆಂತ್ ಕಂಡಿಡಿ ಅಂದಾರ. ಸೊ ದಟ್ ಈಸ್ C divided by nu. Velocity is 3 into 10 to the power of 8. So new value we calculated, that is 7.24 into 10 to the power of 18 ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ 4.14 into 10 to the power of minus 11 meter. ಅದನ್ನ millimeters ನಾಗಿಟ್ರೆ 0.0414 nanometer ಅಂತನೂ ಇಡಬಹುದು. Hence minimum wavelength of X-ray produced is 0.0414 nanometer ಅಂತ ಬಂತು. So easy ಇದೆ, but you have to understand the question. ಏನ್ ಮಾಡಿವಿ? So they have given B value, E value, and by using that one frequency ಮತ್ತು wavelength ಕಂಡಿಡಿ ಅಂದ. Frequency is calculated by using formula nu is equal to E divided by h, and wavelength is calculated by using C by nu. So wavelength we got 0.0414 nanometer, and here nu value we got 7.24 into 10 to the power of 18 hertz anta bantu. So next we shall move to 11.2. So 11.2 ಏನ್ ಕೇಳಿದಾರ ನೋಡ್ರಿ? The work function of cesium metal is 2.14 electron volt. When light of frequency 6 into 10 to the power of 14 hertz is incident on the metal surface, photo emission of electrons occurs. What is the maximum kinetic energy of the emitted electron? B1 stopping potential ಕೇಳ, C1 maximum speed of the emitted electrons ಅಂತ ಕೇಳ್ಯಾರ. A, B, C ಅಂತ 3 ಇದನ್ನ ಕೇಳಿದಾರ ಅವರು. So ಇದನ್ನ let us see how to solve this one. So ಒಂದೊಂದೇ solve ಮಾಡೋಣ. First let us solve 11.2. So 11.2. So first what they have given, work function of cesium metal anna pi naught anta ತಗೊಳ್ಳೋಣ. So that is 2.14 electron volt ಅಂತ ಕೊಟ್ಟಾರ. Frequency of light nu is equal to 6 into 10 to the power of 14 hertz ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ನಾವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಫಸ್ಟ್ ಒನ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ಗಿವನ್ ಬೈ K is equal to h nu minus of pi naught ಅಂತ ತಗೊಂತೀವಿ. h ಅಂದ್ರೆ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟಂಟ್. ಸೊ K ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟಂಟ್ 6.626 into 10 to the power of 34 ಅದರ ವ್ಯಾಲ್ಯೂ ಇಂಟು pi naught, that is into 6 into 10 to the power of 14. So that is frequency of light divided by 1.6 into 10 to the power of minus 19 minus of 2.14 pi naught value. So ಇದನ್ನು simplify ಮಾಡಿದ್ರೆ 2.485 minus of 2.140 is equal to 0.345 electron volt ಅಂತ ಬಂತು. So maximum kinetic energy of the emitted electron is to 0.345 electron volt ಅಂತ ಬಂತು. ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಇನ್ನು B1 ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ V0 ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ therefore that is given by the formula K is equal to E into V0. V0 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ K divided by E ಅಂತ ಬರುತ್ತೆ. So that is given by 0.345 into 1.6 into 10 to the power of minus 19 divided by 1.6 into 10 to the power of minus 19 ಹಾಕಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ we got 0.345 volt ಅಂತ ಬಂತು. So this is B1, stopping potential of the material is 0.345 volt ಅಂತ ಬಂತು. ಅದೇ ತರ C1 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಏನು? ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಪೀಡ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ emitted photon electron nu ಅಂತ ತಗೋಣ. Therefore relation of kinetic energy can be related as K is equal to half mv square. m ಅಂದ್ರೆ mass of the electron. So ಇದರಿಂದ v square is equal to 2 into K divided by m. So 2 as it is ಇರ್ತೀನಿ. K value is 0.345 into 1.6 into 10 to the power of minus 19 divided by 9.1 into 10 to the power of minus 31 ಮಾಡಿದಾಗ so we got 0.1104 into 10 to the power of 12 ಅಂತ ಬಂತು. Therefore V value ಎಷ್ಟು ಬಂತು? 3.323 into 10 to the power of 5 meter per second. ಅದನ್ನ 332.3 kilometer per second ಅಂತಾನೆ ಇಡಬಹುದು. So here this is the V value. Maximum speed of the emitted photon ಎಷ್ಟು ಬಂತು? 332 ಅಂತ ಬಂತು. ಸೊ ಏನ್ ನೋಡ್ರಿ, ಈಸಿ ಐತಿ. A B C ಅಂತ 3 ಸೆಕ್ಷನ್ ಕೇಳಿದ್ರು. ಸೊ ಫಸ್ಟ್ A ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. A ಏನ್ ಕೇಳ್ಯಾರ? K ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿಬೇಕು. K is equal to h nu minus of pi naught ಹಾಕೊಂಡು K ವ್ಯಾಲ್ಯೂ we got 0.345 electron volt ಬಂತು. ಸೊ B1 we calculated K is equal to E into V0 ಯೂಸ್ ಮಾಡಿಕೊಂಡು V0 we got 0.345 volt and C1 we calculated V value as 332.3 kilometer per second ಅಂತ ಬಂತು. So this is the solution for 11.2. So next we shall move to 11.3. So what they asked, so 11.3 ನೋಡ್ರಿ. So here the photoelectric cutoff voltage in a certain experiment is 1.5 volt. What is the maximum kinetic energy of photoelectron emitted ಅಂತ question ಕೇಳಿದಾರ. So let us see how to solve this one. So this is 11.3. ಸೊ 11.3 ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು? ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಕಟ್ ಆಫ್ ವೋಲ್ಟೇಜ್ ಇನ್ನ V0 ಅಂತ ತಗೊಳ್ಳೋಣ. ದಟ್ ಈಸ್ 1.5 ವೋಲ್ಟ್. ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ಎಮಿಟೆಡ್ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಗಿವನ್ ಬೈ ದ ಫಾರ್ಮುಲಾ. ಸೊ ದಟ್ ಈಸ್ KE is equal to E into V0 ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. E ಅಂದ್ರೆ ಏನು? ಚಾರ್ಜ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. So KE is calculated by 1.6 into 10 to the power of minus 19 ಏನದ? ಚಾರ್ಜ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ into 1.5 ಮಾಡ್ತೀವಿ. So KE value we got 2.4 into 10 to the power of minus 19 joule ಅಂತ ಬಂತು. Therefore maximum kinetic energy of the photoelectron emitted is 2.4 into 10 to the power of minus 19 joule ಅಂತ ಕರಿತೀವಿ. So next we shall move to 11.4. So 11.4 ಅಲ್ಲಿ ಏನು ಕೇಳಿದಾರೆ ನೋಡ್ರಿ, monochromatic light of wavelength 632.8 nanometer is produced by helium neon laser. Power emitted is 9.42. So ಎರಡ್ A, B, C ಕೇಳಿದಾರೆ. A ನಲ್ಲಿ find the energy and momentum of each photon in light beam. B one, how many photons per second on the average arrive at the target irradiated by this beam ಅಂತ ಕೇಳಿದಾರ. And third one, how fast does a hydrogen atom have to travel in the orbit to have the same momentum as that of photon ಅಂತ ಕೇಳಿದಾರ. So A, B, C ಇವಾಗ 3 ಕೇಳಿದಾರ. ಸೊ 5 ಮಾರ್ಕ್ಸಿಗೆ A, B ಆದ್ರೂ ಕೇಳ್ಬೋದು, A, B, C ಆದ್ರೂ ಕೇಳ್ಬೋದು. So let us see how to solve this one. So that is 11.4. 11.4. So from the question what they have given, wavelength of monochromatic light lambda they have given, that is 632.8 nanometer ಕೊಟ್ಟಾರ. So ಅದನ್ನ ಮೀಟರ್ ಕನ್ವರ್ಟ್ ಮಾಡೋ 632.8 into 10 to the power of minus 9 meter ಅಂತ ಆಯ್ತು. ಪವರ್ ಎಮಿಟೆಡ್ ಬೈ ದ ಲೇಸರ್ ನ P ಅಂತ ತಗೊಳ್ಳೋಣ, that is 9.42 milliwatt ಅಂತ ತಗೊಳ್ಳೋಣ, that is 9.42 into 10 to the power of minus 3 milliwatt ಅನ್ನ as it is. Planck's constant H value is 6.626 into 10 to the power of minus 34 joules a second. Speed of light c is equal to 3 into 10 to the power of 8 meter per second. Mass of hydrogen atom m is equal to 1.66 into 10 to the power of minus 27 kg. So first one, what we have to calculate, energy of each photon is given by the formula E is equal to hc divided by lambda. So Planck's constant 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 under C value divided by wavelength is 632.8 into 10 to the power of minus 9. So ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ 3.141 into 10 to the power of minus 19 joule ಅಂತ ಬಂತು. So momentum of each photon is given by the formula P is equal to h by lambda. So h value 6.626 into 10 to the power of minus 34 divided by 632.8 ಬಂದಾಗ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 1.047 into 10 to the power of minus 27 kg meter per second ಅಂತ ಬಂತು. ಇದು 8th one. ಇನ್ನು B1 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ, so equation of power can be written as P is equal to N into E, or N ಬೇಕಂದ್ರೆ P divided by E ಅಂತ ತಗೋತೀವಿ. So ಅದನ್ನ simplify, P value is 9.42 into 10 to the power of minus 3 divided by E value is 3.141 into 10 to the power of minus 19. So we got almost equal to 3 into 10 to the power of 16 number of photons per second. So next C1 calculate ಮಾಡ್ಬೇಕಂದ್ರೆ, momentum of hydrogen atom is same as that of momentum of photon. So that is P is equal to 1.047 into 10 to the power of minus 27 kg meter per second. So here P momentum is given by m into V. V and the speed of the hydrogen atom. Therefore V is calculated by P divided by m. P value is 1.047 into 10 to the power of minus 27 divided by mass is 1.66 into 10 to the power of minus 27. Simplify ಮಾಡಿದ್ರೆ 0.621 meter per second ಅಂತ ಬಂತು. ಸೊ ನೋಡ್ರಿ A, B, C ಅಂತ 3 ಇದು ಕೇಳಿದಾರ. ಸೊ ಇಟ್ ಈಸ್ ವೆರಿ ಈಸಿ, ಬಟ್ ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಾಟ್ ದೇ ಆರ್. ಸೊ ವೇವ್ ಲೆಂತ್ ಲ್ಯಾಂಡಾ ಕೊಟ್ಟಿದಾರ, ಪಿ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾರ, ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೊಟ್ಟಾರ, ವೆಲಾಸಿಟಿ ಆಫ್ ಲೈಟ್, ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ A is calculated by using formula E is equal to hc by lambda. And next B ತೊಗೊಂಡಾಗ P is equal to n into E calculate ಮಾಡಿದ್ವಿ. So third one, momentum is calculated by using formula P is equal to m into V. So ಅದನ್ನ modify ಮಾಡ್ಕೊಂಡು V is equal to P by m ಹಾಕಿ calculate ಮಾಡಿದಾಗ we got C1 as answer 0.621 meter per second 1 2. So next we shall move to next problem. So that is 11.5. So 11.5 ಏನು ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. So the energy flux of sunlight reaching the surface of the earth is 1.388 into 10 to the power of 3 Weber per meter square. How many photons per square meter are incident on the earth per second? Assume that the photon in the sunlight have the average wavelength of 550 nanometer. So let us see how to solve 11.5. So 11.5 ಕೂಡ ಈಸಿನೇ ಇದೆ. 11.5. So first what they have given, energy flux of sunlight reaching the surface of earth na pi ಅಂತ ತಗೊಂತೀವಿ. That is 1.388 into 10 to the power of 3 Weber per meter square ಅಂತ ಕೊಟ್ಟಾರ. So power of sunlight per square meter na P is equal to 1.388 into 10 to the power of 3. Power is measured in terms of watt. Speed of light C is equal to 3 into 10 to the power of 8 meter per second ಅಂತ ಕೊಟ್ಟಾರ. Planck's constant H value is 6.626 into 10 to the power of minus 34 joules second. Average wavelength of photon present in sunlight lambda is equal to 550 nanometer. ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಮೀಟರಿಗೆ 550 into 10 to the power of minus 9 meter ಅಂತ ಬಂತು. Number of photons per square meter incident on each per second on the earth each per second n ಅಂತ ತಗೊಳ್ಳೋಣ. Equation of power can be written as, so ಯಾವ ತರ ಕೊಡ್ತೀವಿ, P is equal to n into E. ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿಕೊಂಡು n is calculated by P divided by E is equal to P into lambda divided by E ಅಂದ್ರೆ hc. ಆ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ರಿ. 1.388 into 10 to the power of 3 into 550 into 10 to the power of minus 9 divided by 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 ಅಂತ ಹಾಕಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 3.84 into 10 to the power of 21 photons ಅಂತ ಬಂತು. That is meter square per second. Therefore every second 3.84 into 10 to the power of 21 photons are incident per square meter on the earth ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ನೋಡ್ರಿ 11.5 ಕೂಡ ಈಸಿನೇ ಇದೆ. ಸೊ ಎಲ್ಲಾ ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಟಿದಾರ. ಬೈ ಯೂಸಿಂಗ್ ಫಾರ್ಮುಲಾ P is equal to n into E, ಆ ಫಾರ್ಮುಲಾದಿಂದ so n value is calculated by using formula P divided by E. So that is also written as P lambda divided by E ಅಂದ್ರೆ hc ಅಂತ ಹಾಕಿ so given values ನ substitution ಮಾಡಿ n value we calculated 3.84 into 10 to the power of 21 photons per meter square per second ಅಂತ ಬಂತು. This is the solution for 11.5. So next we shall see 11.6. So 11.6 ಅಲ್ಲಿ ಏನ್ ಕೇಳಿದಾರ, so in an experiment on photoelectric effect, the slope of cutoff voltage versus frequency of incident light is found to be 4.12 into 10 to the power of minus 15 volt per second. Calculate the value of Planck's constant ಅಂತ ಕೇಳಿದಾರ. So let us see how to solve this 11.6. So 11.6 ಏನು ಕೊಟ್ಟಿದ್ದಾರಾ? So slope of cutoff voltage versus frequency of incident light is given by V divided by nu. ಅದನ್ನು ಕೊಟ್ಟಿದ್ದಾರಾ 4.12 into 10 to the power of minus 15 volt per second ಅಂತ ಕೊಟ್ಟಿದ್ದಾರಾ. So V is related to the frequency by using formula h nu is equal to E into V. E ಅಂದ್ರೆ charge of the electron, h and the Planck's constant. Therefore h is calculated by using formula E into V divided by nu ಅಂತ ತಗೊಂಡಾಗ E value is 1.6 into 10 to the power of minus 19. So into 4.12 into 10 to the power of minus 15 ಹಾಕಿದಾಗ after simplification we got 6.592 into 10 to the power of minus 34 joules second ಅಂತ ಬಂತು. Therefore the value of Planck's constant is to 6.592 into 10 to the power of minus 34 joules second ಅಂತ ಬಂತು. So next we shall solve 11.7. So 11.7 ಏನು ಕೇಳಿದ್ದಾರೆ? A 100 watt sodium lamp radiates energy uniform in all directions. Lamp is located at the center of the large sphere that absorbs all the sodium light which is incident on it. Wavelength of sodium light is 589 nanometer. What is the energy per photon associated? Idu eighth one. Next Bth one, at what rate are the photons delivered to the sphere anta Bth one ಕೇಳಿದಾರೆ. So let us A ಮತ್ತು Bth one 2 ಕೇಳಿದಾರೆ ಇದರಲ್ಲಿ. So ಎರಡೂನು ಬೇರೆ ಬೇರೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. So 11.7 we are going to solve. Let us see how to solve that one. 11.7. So in first what they have given, so power of the sodium lamp ಕೊಟ್ಟಿದಾರಾ. So P is equal to 100 watt ಅಂತ ಕೊಟ್ಟಾರ. Wavelength of the emitted sodium light lambda is equal to 589 nanometer ಕೊಟ್ಟಿದಾರ. ಮೀಟರ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 589 into 10 to the power of minus 9 meter ಅಂತ ಆಗುತ್ತಾ. Planck's constant h is equal to 6.626 into 10 to the power of minus 34 joules second ಕೊಟ್ಟಿದ್ದಾರೆ. Speed of light is 3 into 10 to the power of 8 meter per second ಅಂತ ಕೊಟ್ಟಿದ್ದಾರ. So first ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಂದಾರ? So eighth one, energy per photon associated with sodium light is given formula E is equal to hc by lambda. So Planck's constant value 6.626 into 10 to the power of minus 34 into C value is 3 into 10 to the power of 8 divided by wavelength is 589 into 10 to the power of minus 9. Simplify ಮಾಡಿದ್ರೆ 3.37 into 10 to the power of minus 19 joules ಅಂತ ಬಂತು. So ಇದನ್ನ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಸೊ ಇದನ್ನ ಏನ್ ಮಾಡ್ತೀನಿ, ಡಿವೈಡೆಡ್ ಬೈ 1.6 into 10 to the power of minus 19 ಮಾಡಿದ್ರೆ 2.11 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ಬಂತು. ಅದೇ ತರ Bth one ಕ್ಯಾಲ್ಕುಲೇಟ್ ಬೇಕು. ನಂಬರ್ ಆಫ್ ಫೋಟಾನ್ ಡೆಲಿವರ್ಡ್ ಟು ದ ಸ್ಪಿಯರ್ n ಅಂತ ತಗೊಂಡ್ರ ಸೊ ಪವರ್ ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ P is equal to n into E or n is equal to P divided by E ಅಂತ ತಗೊಂಡಾಗ ಪವರ್ is 100, E value is 3.37 into 10 to the power of minus 90. Simplify ಮಾಡಿದಾಗ 2.96 into 10 to the power of 20 photons per second ಅಂತ ಬಂತು. ಇದು Bth answer, ಇದು Ath answer. So next we shall see 11.8. ಸೊ ನೋಡ್ರಿ 11.8 ಅಲ್ಲಿ ಏನ್ ಕೇಳಿದಾರ ಅವರು, ಸೊ ದ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ 11.8. The threshold frequency for a certain metal is 3.3 into 10 to the power of 14 hertz If light of frequency 8.2 into 10 to the power 14 hertz is incident on the metal, predict the cutoff voltage for the photoelectric emission ಅಂತ ಕೇಳಿದಾರ. ಏನ್ ಕೇಳಿದಾರ? Threshold frequency of certain metal they have given, light of frequency they have given, so is incident on the metal, predict the cutoff voltage of the photoelectric emission ಅಂತ ಕೇಳಿದಾರ. So let us solve how to solve this one, that is 11.8. So 11.8 we are going to solve. ಏನ್ ಕೇಳಿದಾರ ಅವರು? So first they have given threshold frequency of metal ಅನ್ನ V0 ಅಂತ ತಗೊಳ್ಳೋಣ, that is 3.3 into 10 to the power of 14 hertz they have given. Frequency of the light incident on the metal frequency nu is equal to, so they have given 8.2 into 10 to the power of 14 hertz. Charge of the electron E is equal to 1.6 into 10 to the power of minus 19 coulomb. So Planck's constant H is 6.626 into 10 to the power of minus 34 joules per second. Cutoff voltage of the photoelectron and V0 and togolana. So equation of cutoff energy is given by the formula E into V0 is equal to H in the bracket E minus V0. So V0 value ಕಂಡುಹಿಡಿಯಬೇಕು. H in the bracket V minus V0 divided by E. So ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ರಿ. H value 6.626 into 10 to the power of minus 34 into, so here frequency nu minus nu naught. Frequency value is 8.2 into 10 to the power of 14 minus of, so frequency of the metal is nu minus nu naught, the frequency into 10 to the power of 14 divided by E value is 1.6 into 10 to the power of minus 19. Simplify ಮಾಡಿದ್ರೆ ಬಂತು 2.0292 volt ಅಂತ ಬಂತು. So this is the solution for 11.8 it is. So next we shall see 11.9. So ಏನ್ ಕೇಳಿದಾರ ನೋಡ್ರಿ 11.9. So 11.9. Work function for a certain metal is 4.2 electron. Will this metal give photoelectric emission for incident radiation of wavelength 330 nanometer ಅಂತ ಕೇಳಿದಾರ. So here 11.9 ಕೂಡ ಈಸಿನೇ ಇದೆ. So work function of certain metal they have given, will metal give photoelectric emission for incident radiation of wavelength 330 nanometer ಅಂತ ಕೇಳಿದಾರ. So let us see how to solve this one. 11.9 it is. 11.9. So 11.9 ಅಲ್ಲಿ ಏನ್ ಕೇಳಿದಾರ? First what they have given, so they have given work function of the metal ಕೊಟ್ಟಿದಾರ. So pi naught is equal to 4.2 electron volt. Charge of the electron E is equal to 1.6 into 10 to the power of minus 19 coulomb. Planck's constant H is equal to 6.626 into 10 to the power of minus 34 joules per second. Wavelength of the incident radiation lambda is equal to 330 nanometer. ಅದನ್ನ ಮೀಟರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 330 into 10 to the power of minus 9 meter. Speed of light is equal to 3 into 10 to the power of 8 meter per second. Energy of the incident photon is given by the formula E is equal to Hc divided by lambda. So value substitution ಮಾಡ್ರಿ. So that is given by 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 divided by 330 into 10 to the power of minus 9. Simplify ಮಾಡಿದ್ರೆ 6 into 10 to the power of minus 19 joules ಅಂತ ಬಂತು. ಅದ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿ ಮಾಡಬೇಕಂದ್ರೆ divided by 1.6 into 10 to the power of minus 19 ಮಾಡಿದ್ರೆ 3.76 electron volt anta bantu. So it can be observed energy of the incident radiation is less than the work function of the metal, hence no photoelectric emission will take place anta answer baribeku. So idu kuda direct given values ana substitution ಮಾಡಿ, so E is calculated by using formula Hc by lambda. E value is equal to 3.76 electron volt. So next we shall move to 11.10. So 11.10 ಏನು ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. So 11.10, light of frequency 7.21 into 10 to the power of 14 hertz is incident on the metal surface. Electrons with the maximum speed is 6 into 10 to the power of 5 meters per second are ejected from the surface. What is the threshold frequency of the photo emission of the electron anta kelidara. So first we have to write the given things, and next we shall try to analyze which formula is useful. So here 11.10 we shall solve. 11.10. So ಏನು ಕೇಳಿದಾರೆ ನೋಡ್ರಿ. So from the question, frequency of the incident photon, so nu is equal to 488 nanometer. ಅದನ್ನ ಮೀಟರ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 488 into 10 to the power of -9 meter ಅಂತ ಬರುತ್ತೆ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಪೀಡ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ V is equal to 6 into 10 to the power of 5 6 into 10 to the power of 5 meter per second. Planck's constant H is equal to 6.62, 6 into 10 to the power of -34 joule second. So mass of the electron M is equal to 9.1 into 10 to the power of -31 kg. So threshold frequency for kinetic energy is written as half mv square is equal to h in the bracket nu minus of nu naught anta bariತೀವಿ. So by using this formula, so we are going to substitute, or what they asked to calculate, threshold frequency in a calculate. So nu naught is equal to, so nu minus mv square divided by 2h use ಮಾಡ್ಕೊಂಡು substitute the value 7.21 into 10 to the power of 14 minus of 9.1 into 10 to the power of -31 into 6 into 10 to the power of 5 whole square divided by 2 into 6.626 into 10 to the power of -34. So ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ನಮ್ಗೆ ಎಷ್ಟು ಬಂತು, 4.738 into 10 to the power of 14 hertz ಅಂತ ಬರುತ್ತೆ. So here therefore threshold frequency for photo emission of electron is, threshold frequency how much we got, so that is 4.738 into 10 to the power of 14 hertz ಅಂತ ಬಂತು. ಎಲ್ಲಾ given value ಯೂಸ್ ಮಾಡ್ಕೊಂಡು just substitute those values, and after simplification we got the threshold frequency as 4.738 into 10 to the power of 14 hertz. So this is the solution for 11.10.